Welcome back to the Explainer Focused Learners. I am absolutely thrilled you're here today because, well, we are diving into one of the most fascinating tensions in AI right now. We're looking at a brilliant repository breakdown by Kalyan KS, and it really highlights the absolute must-have architecture of modern artificial intelligence. I mean, think about it. We've got these unbelievably sophisticated LLMs today, right? But to make them actually reliable in the real world, we have to bridge this massive gap between their internal reasoning and, well, reality. Okay, let's dive into this. It's the big question, isn't it? If LLMs are so undeniably powerful, I mean, they write code, draft essays, summarize entire books in seconds, why do we need to bolt anything else onto them? Why on earth do developers need external systems to help out an artificial brain that has literally already read half the internet? Well, to answer that, here is our roadmap for today. We'll start with the limits of LLMs, then look at the long context illusion, and finally wrap up with real-world RAG challenges.
All right, part one, the limits of LLMs. Let's get into it. So the primary culprit we're dealing with here is the knowledge cutoff. You know the drill. When an LLM finishes its training, its knowledge is essentially frozen in amber. It's stuck in time. This creates what we call static knowledge. And because of this, the model is naturally going to struggle if you ask it about yesterday's news or, crucially, any private proprietary company data that obviously wasn't in its original training corpus. When it relies purely on that static knowledge, the model is essentially flying blind to the present day. And this brilliantly illustrates the stark reality developers are facing right now. Relying on an LLM by itself, it leaves you wide open to incomplete or just flat-out outdated answers because of that static knowledge base. But when you pair that LLM with RAG, Retrieval-Augmented Generation, boom, you transform that static knowledge into dynamic intelligence. By pulling in real-time external context, you're empowering the LLM to give highly accurate responses based on the absolute most up-to-date information out there. It's a total game changer.
Which brings us to section 2, the long context illusion. Now, this leads to a super common enterprise question we hear all the time. Is RAG actually still relevant in the era of long context LLMs? I mean, if we can just copy-paste an entire massive database or a giant technical manual right into the prompt window of these new models, doesn't that make the whole concept of RAG kind of obsolete? Well, the source text tackles this head-on, and spoiler alert, the answer is a resounding yes. RAG is still incredibly relevant. Here's why RAG remains so crucial. Relying purely on long context models introduces 3 massive roadblocks. We're talking about the lost-in-the-middle phenomenon, notoriously high API costs, and vastly increased latency. Because look, just because a model has the theoretical capacity to swallow a gigantic sequence of text, that definitely doesn't mean it handles it efficiently, or affordably for that matter. Let's actually look a bit closer at that first problem, the lost-in-the-middle phenomenon. It's a huge hurdle. Even if you feed an LLM a massive, sprawling document, it really struggles to find the most relevant information if it happens to be buried deep inside the middle of that context. It's literally like handing someone a 1,000-page book, asking them one highly specific question, and they just read the whole thing but completely glaze over the single paragraph on page 500 that actually matters. When the LLM can't pinpoint that needle in the haystack, the quality and accuracy of your generated response just tanks. So, how does this play out in real operational realities? Relying solely on long context processing forces your system to digest those massive, lengthy sequences of data in every single API call. That is going to burn through enterprise budgets so fast, and it slows down response times considerably. RAG, on the other hand, acts way more like a surgical tool. It first retrieves only the absolute most relevant information from your external sources, and then it sends just that tiny, highly relevant snippet to the LLM. The result? You still get those highly accurate responses, but in a way that is vastly more cost-efficient and incredibly fast. All right, moving right along to section 3, real-world RAG challenges. Now, what's really interesting here is how the source repository systematically breaks down the 4 fundamental challenges of RAG systems. We're looking at scalability, latency, hallucination risk, and bias and noise. RAG might be the hero of our story, but it requires some serious optimization. Let's break these down a bit further so we can truly understand what developers are up against. Let's start with scalability and latency. These truly act as the twin bottlenecks of real-time AI applications. The source notes that searching and retrieving from large, dynamic knowledge sources quickly, it requires a ton of computing power and highly optimized indexing. If your indexing isn't optimized, searching is going to be incredibly expensive, or it'll just take forever. And compounding this is the latency issue. By definition, RAG is a two-step process, right? First, you retrieve the data, and then you generate the answer. Without some very careful optimization, that inherent delay makes the system totally unsuitable for real-time applications where a user is sitting there expecting an instant response. And then we fall into the data quality trap, hallucinations and noise. This is absolutely critical for any focused learner to grasp. RAG does not magically cure hallucinations if your underlying data is garbage. The repository warns that even with the retrieval system in place, the model might still confidently generate plausible but completely unsupported details if the retrieved data is ambiguous or just insufficient. Plus, retrieved content can carry its own biases, errors, or just irrelevant noise from web sources. If you feed the LLM noisy or biased retrieved data, those errors are going to propagate directly into your final output. At the end of the day, the AI is only as good as the context you successfully retrieve for it.
So the crucial point is that mastering these specific hurdles, optimizing that indexing, cutting down latency, and rigorously ensuring data quality, it's not optional anymore. It is a mandatory skill set. That is exactly why this source material exists in the first place. The repository we're referencing actually curates a list of over 120 LLM, RAG, and agent-related libraries. It serves as an absolutely vital toolkit for the data scientists and AI engineers who are in the trenches right now, working to overcome these exact scaling and quality challenges to build applications we can actually rely on.
Which brings us to our final thought for today's explainer. We've seen how static knowledge severely limits base models. We've explored why throwing massive context windows at the problem isn't a standalone fix. And we've walked through the intense engineering required to make retrieval-augmented generation actually work in the real world. But as these large language models continue to rapidly evolve, I want to leave you with this question to chew on. Will RAG remain the permanent bridge to accuracy in AI, or is it just a complex stepping stone to whatever comes next? Think about it. Thank you so much for joining me. Keep learning, and I'll see you in the next explainer.